And welcome, YouTube audience. We were thinking about canceling today's stream, but we decided to go through with it because it's a big day for space weather, as it's been for days. So we'll be talking about space weather and Earth weather, and perhaps even your viewer comments. So don't forget to press the like button. If you're new to the channel, press subscribe. Otherwise, you will not see the world's most comprehensive daily space weather content in your YouTube feed. You'll have to search and things, and who wants to do that, right? So, thanks for leaving a comment. Barbarian 1111. Solar switchback. Maybe. Could you elaborate on what that means? Anyway, I've moved up to the studio here because we're going to cover things like the sunspot number, which has now gotten to around 150, exactly as forecasted. No surprise there to our regular viewers. And let's see what's going on the closest star. So, of course, like I said a minute ago, we were considering canceling this stream for a whole litany of reasons, not the least of which being my personal basic survival. Barbarian 1111 says, intense S-shaped zigzag kinks in the sun's magnetic field that cause the solar wind to bend back on itself, often reversing direction. Ah, yes, a discovery made by the Parker Solar Probe, it sounds like you're talking about there. Yeah, solar switchbacks. Those are a thing because the magnetic field reverses when the polarity switches. So it's some electrodynamics there in the propagation of the solar wind. So yeah, I mean, solar switchbacks, it's a thing. And, we'll show some of those actually today on the stream because those solar switchbacks show up in a bunch of the different data sets at which we look. So the real place to watch right now is this sunspot up here, and it is quite magnetically complex. So it's got big time magnetic shear. We'll show you the details about that momentarily. Yeah, thanks for commenting, Barbarian 1111. So we've had, in the past 24 hours, the background X-ray flux has been something like an M-class background X-ray flux. So a big solar uptick happening here. Pardon my gray screen, just waiting for pages to load with our blazingly fast internet connection. It's something that actually works. All right, so let's take a look at gray goo. Have you been experiencing the gray goo problem on the internet? Well, we certainly have. Some AI slop needs to be rebranded. AI sludge. All right, so let's see if University of Reading is forecasting any new Earth-directed coronal mass ejections. There's their Enlil spiral. Let me press play and press repeat. Okay, so they did model a glancing blow there. That was what we forecasted, so that looks like it's going to be right. It is a slow-moving impact, so that solar storm probably expected more like later in the day on Thursday. So it was slow-moving. It's pretty tough to judge the speed of a thing that's coming directly towards you, right? So yeah, part of that CME will likely strike Earth, as shown in that data set. As far as the real-time solar wind conditions, we'll tell you the solar wind speed and density and the magnetic fields and so forth. So there it is. There's a solar wind data from ACE right now, from ACE. Total field is 5 nanotesla with a BZ of +2. Solar wind density about 3.5 protons per cubic centimeter. Solar wind velocity here amazingly slow, 290, barely 300 kilometers a second. It looks higher than that. It's not scanning. I don't know. 290 kilometers per second is around where the solar wind speed is at the moment. Those are solar minimum like conditions. So the next time we do see a hit, whether it's a high speed coronal hole stream or more likely that incoming CME, we will see a big signal in the solar wind data. To new viewers, just a reminder, it is measured out here at Lagrangian point 1, about 1 million miles from Earth, or 1/93rd of the way to the sun. They orbit this gravitational equilibrium point, Lagrange 1. There is a real-time simulation of the ACE, and discover that the ACE, which is the one we're currently using, is located right here. Earth's magnetosphere is looking pretty calm right now. The majority of the pressure there is in the magnetotail side, as modeled by the Space Weather Modeling Framework, courtesy UMichigan. Shout out to the Wolverines. Go Wolverines! Is it Red Dawn where you're located? Have you been invaded by crap and nonsense? Well, a lot of YouTube viewers would tend to agree with you. There are our GOES magnetometers measuring Earth's magnetic field from inside the magnetosphere. And since space weather has been calm, the magnetosphere, the magnetometers have shown smooth curves. NOAA's forecast for space weather is late in the day on the 5th, like I just said, a minor geomagnetic storm from the glancing blow from the CME from the X8, associated with, I should say, not from the X8 flare, because we don't conflate flares and coronal mass ejections on the channel. A lot of people think there's some way that you can guess how strong a geomagnetic storm is going to be based on the solar flare, and that couldn't be further from the truth, because solar flares and coronal mass ejections are separate phenomena. So solar flares are X-ray photons in the X-ray frequency. Coronal mass ejections are gas blasting out of the solar corona, matter, as opposed to electromagnetic radiation, photons, light, like radio and infrared and visible light and ultraviolet and X-rays and gamma rays and petatrons. Electromagnetic radiation, high frequency photons. That's a solar flare. Coronal mass ejections are matter. Think of a fan versus a flashlight. That's sort of an appropriate analogy there. Now, the second most important data set to solar activity to sunspot number is the 10.7 centimeter radio flux, which is what we're showing here. It's all the way up to 174 solar flux units. So that is a big uptick in solar activity, as everybody is probably well aware of. Yeah, a lot of fear-mongering, a lot of people consuming nonsense on YouTube, listening to confident-sounding charlatans or grifters or regular old everyday frauds, and thinking that they know what they're talking about. So here's sunspot number above 150, exactly where we forecasted it to be, because of rising sunspots on that eastern limb, which we will show you. But first, the coronagraph. Here is the GOES 19. And we're looking to see if we see any additional Earth-directed coronal mass ejections. Doesn't look like it. Let's play it one more time and then view stereo A to get a different angle. A few months ahead, orbitally speaking, from stereo A's coronagraph. So here's the CME that's already on the way. We're going to bring up a new applet here. At the Integrated Space Weather Analysis Center, you just click Browse, click Solar, click Stereo Ahead Coronagraph 2 Space Weather Beacon. Hey there, all of the sun. Oh, great. It's good to hear that extraterrestrials come in peace, because we definitely don't need war. We definitely don't need war. That would be even less optimal than the current situation, which is far from optimal. And that's part of the reason why we almost didn't do the stream today, because because personal technical difficulties that are frankly putting me on the borderline of being legit depressed. So yeah, there's stereo A. It does show the date stamps. We're not seeing any new Earth-directed space weather as far as I can tell here. So it looks like the coast is clear, except for a coronal hole high-speed stream coming in about 2 or 3 days, as well as that coronal mass ejection. So this is where planets are located. Keep in mind, planets aren't really space weather, because space weather is only what occurs between the Earth and the Sun, the D layer of the ionosphere to the photosphere of the Sun. But we like people to be oriented. This is where the celestial bodies are located. And these pink halos, those are because Jupiter and Uranus are currently in retrograde, which means they're moving very slowly in the opposite direction of the background stars. Proton flux remains flatlined here. No solar energetic particle events of note. And here's that GOES X-ray flux we were talking about. Background X-ray flux for the past 24 hours is something like an M2. So big uptick here in sunspot number, radio flux, X-ray flux, and yeah, some significant M-class flares, which let's take a look at those. Will happen. This belongs down here. All right, so let's bring up, we're going to look at 94 angstroms. You're going to see a bunch of flares coming out of that sunspot group. So let's play a run of that. The GOES 19 now depicts 12 hours, I think. So eyes on this sunspot group. It is definitely the star of the star. So it still does have complex magnetic fields, which we're going to show you the breakdown of here in a minute. In other words, the solar flare watch is not expiring. All right, so let's take a look at some more data here. First, the heliosphere, courtesy of the top view ecliptic plane field plot. We'll just look at today, and here is the magnetism of the heliosphere. Earth remains in that South Pole-oriented magnetic sector, and what that ultimately means is that the magnetic field lines are pointing toward the Sun. North Pole sectors feature magnetic field lines pointing away from the Sun. And here's our coronal hole line of sight plot. We'll show the same period here. Just today's data to show you where coronal holes are currently located. There you go. South Pole-oriented equatorial coronal holes here rotating in. Again, 2 or 3 days until we'll see a high-speed wind from that. It'll be marked by an increase in the solar wind density, then a dip in the density, and an increase in the solar wind velocity. That's the coronal hole line of sight plot from the NSO, the National Sunspot Observatory. Next, magnetograms. These are ground-based magnetograms here. We'll look at, let's go to Cerro Tololo today. And we're going to just look at today because we want to get an idea of the ongoing solar flare watch. And this sunspot is quite magnetically complex still. As you can see, there's stark white and stark black right next to each other. That is high magnetic shear right there. So very high probability of additional large solar flares, including the possibility of X-class events. So that's a magnetogram. We'll go to El Teide for the red light imagery. There's El Teide, Spain. And that is a large and complex sunspot. We also do have a new sunspot that just rose and or formed down here. This one is also magnetically complex. So if we come back to the magnetogram, this is a beta gamma class sunspot, just not beta gamma delta class like this sunspot group, I mean, this one here is very volatile. All right. This one here can produce some flares, so don't be surprised to see that in the coming day or days. This group here's got some magnetic complexity too, but of course, this is the spot to watch. Everybody knows this, so let's don't dwell on it. Here are filaments. As you can see, the Eric Schmidt filament, named for one of the Google founders, is still intact over here, setting on that western limb. And the likelihood of it producing a proton event is now kind of high, because sometimes these things blast off from way over here on the western limb and create solar energetic particle events. So there is a possibility for that. We also see more active regions rising here behind the eastern limb. Of course, this extremely complex sunspot group, this magnetically complex sunspot group, and even this group here. I mean, you can see the activity there on the hydrogen alpha imagery. The dark features show up here as that's less hydrogen, and the bright features are more hydrogen. This is a chemically complex cocktail, or CCC. Yeah, 4366 is the number of that sunspot group. And thanks for dropping that in the comments. Barbarian 1111. By the way, if you want to name filaments as we did this one after Eric Schmidt, you can do it over on Twitter, known by insane Elon Musk fanboy sycophant lunatics as X, which can never be a brand, but I'm going to keep calling it Twitter because that is a brand, and Elon is steadily destroying that brand and convincing people that he's restored free speech on social media, while censorship is actually higher, more accounts banned, and bots not eliminated. Thanks, Elon. You're doing a fine job over there. Just a fine job. GOES electron flux here, just getting back into warning levels for the GOES 18 as the electron storm continues. And your GPSs are going to work badly. Here's a coupled thermosphere, ionosphere, plasmasphere electrodynamics model. That's going to show you where the GPS errors are most likely. Oh, you're not on Twitter because Elon Musk sucks at everything? Yeah, I don't blame you. It's pathetic. But we're a business, so we're on Twitter and on LinkedIn and on Feces Book and on Stinkstagram. We're also on the Don't Die app. Everybody should install the Don't Die app. It's real social media. Are you familiar with Brian Johnson? A lot of people don't like him because I guess it's now subversive to try to increase people's longevity. But there's this guy called Brian Johnson who has this brand called Don't Die, and there's a social media app, and you should definitely install it. We're over there, and there's exclusive content there that you're not going to see anywhere else. It's real social media. People are trying to help each other out, and it's like an actual community, not a corporate pile of shit like Feces Book. Anyway, like I said, though, that's where their GPS errors are going to be most likely. It does show time and date stamps, so you're welcome. Expect radio blackouts around the equator. I mean, that's just a feature of solar flaring. And with an active sunspot like 4366, the likelihood, like I said earlier, of X-class flares is very high. And you can see those equatorial radio blackouts happening consistent with the flaring. It attenuates the ionosphere, folks. It attenuates the ionosphere, and it makes your radio signal blast off into space instead of refracting down to your radio target. So that gives you an idea of where the blackouts are going to happen. It's the deabsorption region predictions, or DRAP. You got to have an acronym on everything, folks. It's the DRAP, not to be confused with Wu-Tang Clan, which is the A-list rap. All right, so this is just a diagram of the layers of the ionosphere. What we were showing there was the F layer and the D layer and so on. Here is the ionosphere in graphical display from the Australian Government Bureau of Meteorology. So there's the anomalogram, anomaly in megahertz from a 30-day median, and there's the ionosonde, depicting the vibrational frequency of the F layer of the ionosphere, which, not to be confused with the D layer, is up here about 100 kilometers higher or so average. Next, we'll transition into Earth weather. Yeah, Earth weather. Here's the Atlantic sunrise over the Atlantic. It's the best kind of Atlantic sunrise, the kind over the Atlantic. And let's shrink that down. We'll put your chats on the screen here. Just give me a minute because I ain't got the stream opened on the PC yet. Flux rhymes with Musk. Well, I mean, you do have some assonance there. It's not really a rhyme, but you could say that it's assonance. Or since it's pertaining to Elon Musk, you could say it's asshappenance. That might be more accurate. What an absolute plonker. Hey, Elon, if you're watching the stream, how about raising your own children? Might be a good idea. Might be a good idea. Yeah, so thanks to everybody who left comments. We're going to cover some Earth weather things here. It's going to be pretty chill. Stream isn't going to be much longer. But there are your chats. Thanks to everybody who commented, pressed like, subscribe. Most importantly, press that share button, because even though we pay for ads, YouTube does a frankly pathetic job to get this content onto screens, even though it's the world's most comprehensive daily space weather content. And it's not even close. It's not even close. So there's that. And let's talk more Earth weather. But first, links in the description include links to the merch shop. If you haven't seen the SNN Least Busted Name and News merch shop, well, here's a quick peek. And let's bring up a nice old one here. How about Do the Math? This is a great one to use online. Do the math, dude. Here's your equation. 8 equals capital D. Try to stop sucking at math. Did you know that everything you do is math? Yeah. If you can do a really hard thing like play guitar or figure skate, or maybe you're a skateboarder, guess what? You're really good at math. So what this is ultimately saying is do the thing, because all your brain does is math. It's basically binary code. It's like a series of ones and zeros because neurons are simply on-off switches. So do the math. Don't suck at it. Here's the equation. 8 equals capital D. And you get the idea. Don't be a dick. Don't be a dick. Don't suck at math. Here's our U.S. water vapor map. We have a blocking feature here over the southwestern U.S. and some cold moisture coming down from Canada. As another atmospheric river arrives over here coming in from the Pacific, it's the Pineapple Express. Let's look a little more closely at that so that we can use a buzzword that gets people very spooked. Ooh, look out, folks. It's an atmospheric river. Oh my God, what are we going to do? And the answer is get precipitation and clouds. It's an atmospheric river, folks. Oh my God. Get in your bunkers. If I had a bunker, I think I would stay in the bunker for a year and not like be on social. If I had a choice, never mind. Anyway, for our Lehigh Valley viewers, here is the situation. It's a little on the cool side at 11 degrees Fahrenheit. Those are the conditions at Lehigh Valley International Airport. 11 degrees Fahrenheit. Today, a forecast high near 30. Tomorrow, forecast high near 29. And Thursday, forecast high near 28. That's basically a heat wave considering the heat freeze that we've been in. So we'll take it. We'll take it. Next U.S. Doppler radar map. And we've got some lake effect snow, it looks like, once again. Some snow showers making their way across Pennsylvania and, well, across parts of the Midwest. Here's our windy.com map. And let's take a look at something we don't normally look at today. How about snow depth? There's a high albedo right now over the United States. Look at that. That's a shiny country right there. As the lower 48 are like 35% covered with snow. Pretty snowy, pretty snowy. And it's definitely Sugar Town here in Lehigh Valley. It's only saying there's like 5 inches, 6.5 inches. Yeah, that's about right. Maybe 7 inches. That's probably about right. But there is like an Arctic style frozen layer on top of it. And that makes it very slow to melt. So yeah, lots of snow. And it's going to be falling off roofs, by the way. So just, be aware of that. I'm looking around, I'm seeing piles of drifted snow and ice on roofs. So it's going to start coming down, and some of it's going to come down in big sheets and chunks. So watch where you stand. If you hear the sound of sliding ice above you, like know where it's going to land at least. You can stand real close to the building or real far from the building, but that sloped roof, it could be a little bit hazardous. So here's our lightning maps. Lightningmaps.org is what I like to consult to see where the lightning strikes are. And the majority of Earth's lightning strikes right now are over here, north of Saudi Arabia. Some thunderstorm activity there, south of the Caspian, south of the Black Sea, and west of the Caspian. And let's show some forecasts here. We're going to show a snow forecast once again because that is the most logistical hassle that you're going to get. Are we going to get more nuisance snow, or are we going to get some significant snow? I think just a nuisance snow, but here's a 72-hour GFS forecast. Let me just generate that for you here. We show 3-day forecasts because they tend to be accurate. If you think humans are forecasting the climate, it would probably be optimal to be able to forecast the weather a full week in advance, but we can't really do that. Certainly not in the mid-Atlantic states, and the snow forecast has been reduced. But places like West Virginia are going to get blanketed again, also parts of Kentucky, Virginia, Ohio, Indiana, Minnesota, Wisconsin. But there's the map, 72-hour GFS forecast. Read them and weep. Unless you like that stuff, then celebrate. Celebrate weather that you like. Next, nullschool.net, we're going to show the Earth winds here. From a macro perspective, there are the surface winds of the Western world. And let's show the 250 hectopascal winds, otherwise known as the jet streams. There you go. There are the jet streams. A big jet stream intensification here over the North Atlantic. And a split up jet stream here with big kinks in it over that Eastern Pacific. Eastern world's jet streams are looking like this, mostly staying south of Australia here. Surface winds depicted thusly. Pretty windy in the Pacific Ocean right now in aggregate. Last but not least, the central world. Shout out to our viewers from all around the planet. Those are your surface winds. Here are your jet streams. Let's cut back to the closest star, the most interesting one at which to gaze. Let's look at the 171 angstroms wavelength, the house favorite, and close this stream out. Thanks, everybody, for tuning in. Whether you viewed live or in syndication, don't forget to press the share button so that you can share this video on, quote, social media, end quote. And it's in quotes because it's social media is about as social as locking yourself in the basement chained to the wall with only bottles of cheap vodka and canned peas for a month. That's how social media is. I'm pretty social, but right now I'm feeling pretty antisocial. I would seriously lock myself in a bunker right now, given the choice. So if you've got a bunker, hit us up on Discord and maybe I'll move into your bunker. It could be great, right? Anyway, that's the closest star for the past about 12 hours in the house favorite wavelength. 171 angstroms is one of the ionized iron species covered by the GOES 19 SUVI. It's the extreme ultraviolet spectrum. Higher frequency than visible light, lower frequency than, say, X-rays. Anyway, it's time to shut this thing down. Congratulations on realizing the Smash News Network least busted name in news exists. More content likely coming out today, but don't hold your breath. We'll see you soon. In the meantime, I've been your host, Dan, aka Smash-O-Mash, signing off. And until it gets here, may that solar wind be at your back.